The kinds of questions that interest me are how we can use surfaces to get things to organize the way that we want to.
It's really all around us. These types of materials are things we interact with every single day.
We essentially create a material system that can open up a vast potential for chemical innovation.
I'm trying to use atomically smooth surfaces to organize organic molecules. Organic molecules have some advantages in that they're cheaper, they're usually easier to process, they're usually greener, but they don't have properties that are the equivalent of those silicon chips. And so if we can make those molecules organize and order, we may be able to improve their properties so that they're at least a little more competitive with the silicon. It's anything that organic electronics could be used for. So it's light emitting diodes, it's solar cells, it's all of those electronic applications that we're currently using silicon for.
We study the motion, interaction, and dynamics of nanoscale to microscale particles and fluids and in interfaces. We're interested in understanding how these particles assemble and influence the properties of the fluids that they're dispersed in and the interfaces that they're near. One project that we have is with a coatings company where we're using optical methods to track how the various constituents of the coating behave in the fluid. And their interest is understanding how those constituents influence the rheology and the mechanics of the fluid as it's drying. You can then use that information in order to track how the paint is evolving in a manufacturing environment, and that's really important for avoiding defects that might arise when you're painting a substrate.
Carbon nanotubes research, our current focus is on creating engineered organic color centers, which can be chemically implanted on nanomaterials host to tune light in a broad spectral region, including the near-infrared region, which is very important for advanced technological applications in biomedical imaging and sensing advancement. These engineered organic color centers, which have unique optical and precise biological functionalities, which can be used as a biocompatible cancer cell targeting multicolor fluorescent probes.
Dr. Wirth and Dr. Au and I are all similar. We're looking at how can we use the properties of things at the nanoscale to self-assemble. How can we use these nanoscale specificities is actually one of the keys to nanoscale research and specifically to our kind of subgroup here at CSU.